Hi guys, welcome back to a new video. So on this video I will show you how to step by step overclock your more affordable 9th generation Coffee Lake model, the Core i7 9700K, on the EVGA Z390 Dark, and how to test the stability of your overclocked CPU. So when you just land to the BIOS, when you press delete on your keyboard, you should see a screen like this pretty much. So we will select and enter setup. So advanced configuration, you can either use keyboard or mouse. I will use a mouse for this purpose, keyboard for this purpose. And here on the main screen of the BIOS we can see that the CPU is Core i7 9700K at 3.6 GHz stock, and it's reading around like 27 degrees Celsius as stock temperature. Now I will not be covering memory overclocking on this tutorial to make it at least somewhat more simple and faster, so I can make a separate video later, and I also have lots of Intel overclocking videos on my channel where I overclock the memories. So for most guys, more like beginners, I would just recommend you use XMP, or if you have purchased like a very high-end DDR4 kit, preferably with Samsung BDI memory ICs, and especially if they are the more newer A2 PCB, you can Google that to see what it's all about. If you have such a kit like G-Skill 4133 MHz Cas17 or 4400 Cas19 for example, or some really high-end kit from Patriot or Galax, you can try my 5.2 GHz daily profile, which was integrated to the BIOS like roughly over 1 year ago. So when you have highlighted the OC tab on the BIOS, just press left button on your keyboard to go to the extras, then down, and here you can find like stress test, OC robot, OC profiles, and BIOS update. Of course, you may want to update your BIOS if you have the stock one that originally came with the board, and maybe use some newer one if you want to have the security things on your BIOS, or if you want to try the more like dedicated overclocking BIOS, which is released for the Z390 Dark at xdevs.com and the EVGA OC Lab forum. You can update the BIOS using this feature over here. You just need to place the BIOS file to an empty USB stick that has been formatted into FAT32 format. But anyways, so if you have some of the memory kits I just mentioned, a good one you may want to try by going to the OC profiles over here, my 4300 171818 5.2 GHz daily profile. Buildzoid, I think he tried these profiles briefly, and he said the memory or the profile is quite optimistic about your memory, so that is at least partly true. So you can load it and you can try it if you want, but you do need to you must have at least somewhat good Samsung BDI kit, preferably with A2 PCB. Anyways, this memory profile is good for even just lower frequencies without having to touch the timings. So now the profile suggests you to put 4300, but actually I will be lowering the frequency to 4133, and I will lower the voltage to 1.43. I'm using exactly the same memory sticks which I used when I made this profile. So I'm using the 4133 MHz HyperX Predator Cas19 sticks. So you can use like frequency ranging from 4000 even up to 4400 with these timings. So you can start at like 4000 or 4133. If that is stable in HEI memtest in Windows, you can increase the frequency step by step. But I will just lower the frequency to 4133 and 1.43 voltage, and I will keep all the timings that are included in the profile. Not all are set, but some of the more important ones are. Then we will be testing the CPU in this video mostly, so I will start at a frequency of 4.9 GHz. I can start, I'm sure it will do 4.5 mesh. For this testing purpose I will put the AVX negative offset to 0, but for daily purpose you should use a value ranging from 1 to 3 here. Good thing about this feature is that it will use a lower core frequency multiplier for any software or application that can utilize the AVX instruction sets. AVX instruction sets are more efficient, so those applications are better performing if they can utilize the AVX offsets, the AVX instruction sets, but it will just make the CPU more hot. So it will use a lot more current if it can utilize those AVX instruction sets. So for example, if your CPU runs Cinebench with core temperatures of 75 degrees, if it can utilize the AVX instruction sets in those applications that can utilize them, the core temperature will go to like 85 or 90 degrees. So you have to bear that in mind when you test the CPU, like briefly in non-AVX situations first, so that you need to have some headroom for AVX programs. So just for this testing purpose now I will put the ratio offset to 0, so it will run the max frequency for any kind of application. So I will start at 4.9, 4.5 on the mesh, or on the cache. Mesh is for X299, sorry. So 4.5 on the cache. I would always use 100 base clock because it's just more easier. Then I will start with a VCO of 1.25 volts. This depends greatly on your cooling solution. On this testing purpose, on this testing video, I'm using a very good custom water cooling loop. If you are just using some kind of a simple air cooler, you may want to even try as low as 1.15 volts first. Use override for testing purposes, but once you have found the optimal settings, you may want to use the adaptive. So adaptive just means it will go down when it's at idle, and it will hit the max set-in voltage when it goes under load. But I just personally use override for everything because I'm quite lazy and it's just so much easier. But anyways, if you have just simple air cooling, you may want to try, or you may want to start with relatively low value of 1.15 for example. But as I've tested many of these CPUs already and I know that my cooling is good, I will use a value of 1.25. VCO V-droop, it's the same setting as CPU load line calibration on most of the other competitors' PowerCs. So the whole idea of load line calibration is to compensate the voltage drop when the CPU goes under load. So if there was no load line calibration at all and I have set the desired VCO to 1.25, it would have this value when the CPU is just sitting idle on the desktop, and when I put any kind of like proper load on the CPU, for example if I started Cinebench, the VCO would drop to, for example, like 1.15 when the current that the CPU starts to pull goes up. So with this setting or load line calibration, we can compensate that drop so that it will maintain the desired voltage across any kind of load scenario. And on the Z390 Dark, the best values to use here are either the minus 25% less droop or minus 50% small droop. Minus 25 is more accurate than minus 50%. So if I have set 1.25 with minus 25%, the accurate value under load, I think it was like 1.26, and minus 50% will overshoot a little bit more. So if I have minus 50%, the value would be around 1.25 when idle, and like 1.275 when under load. So we don't want too much drop, but we don't want any kind of too much overshoot either. So we want the value under load to be as close as possible to the set idle value. So I would recommend you use minus 25% here. So it should be alright. You can't really know the exact value under load without testing the value properly with a dedicated multimeter, and that's what I did when I was testing these values myself, like over 1 year ago. VCore Pwm Frequency. This just makes the CPU power delivery more responsive. So if you increase the value from the stock 300, it will make it a little bit more responding, but it will make the efficiency worse. So it will just increase the VRM temperatures a little bit. I would use a value of 800 here. If the BIOS allows you to set any higher than that, don't, because for example the 900 and 1000 values don't work well. They often cause some weird instability issues. So if you want to use any value here, use 800. These I don't mind on touching. VCCSA and VCCIO, these are for memory overclocking. I recommend you use a value from 1.15 to 1.25 here. For testing purposes you can increase even up to 1.45, but don't use so high for daily purposes. So for now I will just use 1.25, but as I said, you may want to even just use like 1.15. Rest can be at auto. PCH you don't have to touch. And that's pretty much it. In hardware monitor configuration on the advanced tab, you may want to if you want to use the debug LED monitoring feature, you may want to change this to the PWM temperature, for example, so you can monitor the VRM temperatures in real time. And if you have, for example, a window in your case, you can still see the value quite accurately, so that's quite handy. That's pretty much it. No need to touch anything else, and we have boot mode select as UEFI. So now we can just F10, save and exit, and see how the performance looks like in the OS. Okay, now we should be landing on the desktop. So I'm actually using the same operating system what I used on my 10980XE lapping video, but it doesn't really matter. We can see the stability of the 9700K using the same OS. It doesn't really matter. So if we open CPU Z, we can see that the CPU is running at 4.9 GHz, but the VCore value isn't measured correctly, so you cannot really trust this. So on many motherboard models, the CPU Z just cannot measure the voltage accurately, and that is why I recommend, if you use Z390 Dark, to get the Elite software. I can even link the light version of Elite for this particular motherboard in the description down below, so you can use this. This works quite well with this board, so at least you can set the clocks and similar using this version. And here in the monitoring tab we can see CPU VCore is measuring 1.25, pretty much spot on, and DIM is 1.435, around the same what we set. And you can use this software to overclock the CPU for voltages. It doesn't always work, but for air or water use you can use this, even though it reads the first value incorrectly. But anyways, so you can use this to measure the correct VCore value. But anyways, so now let's just see how the temperatures and similar look like. For initial testing, you can use something like Cinebench R15 to quickly test the performance and stability. This isn't enough to determine daily stability. So if you crash in this, if you pass Cinebench stable, it doesn't guarantee that it will be stable in everything like gaming and similar. And look at the temperatures, around 50 degrees only. The average of core maximums, that is really small value. And the score is 1608. And I'm pretty sure that this will be stable in everything. But now we can just keep going and see where it will stop. So I will open Elite. You can use this or Intel XTU, or you could just go back to the BIOS and set the value, the multiplier there. But I will use the software to set the CPU core multiplier from 4.9 to 50. So that means 5 GHz across all of the 8 cores, and apply. And see, it's now 100 times 50, so 5 GHz. And vCore is still the same, we didn't touch the voltages at all. And now we can run again, see if it's still stable. And I'm pretty sure it will pass. Temperatures are mostly affected by the voltage, but when you increase the frequency, the amount of amps or current the CPU draws will also go up. So total power consumption and temperatures aren't only affected by the voltage, the clock speed affects them too. And now we can see that the score went up again, so 1648. And we can pretty much keep going. So now I will open this software again. I will set the multiplier to 5.1. And now it's at 5.1 GHz measured by CPU Z. And run it again. Temperatures are going up a little bit, so now the max is already at 54. Like 3 degrees higher, 3 to 4 degrees higher than how we started at 4.9. Seems to run well. But again, everything is affected by the cooling solution you use. So if you just use a simple air cooler, you obviously have to start at much lower voltage and clock speed. So if you use a vCore 1.15 volts as starting point, you may want to use a frequency of 4.5, for example, to start with. And now, as we are still stable, we can keep going. We just want to know where we will crash. So I will set at 5.2. The cache isn't that important on these CPUs. So cache comes in at a spot of 3 in terms of importance when it comes to gaining more performance by overclocking. CPU core is the most important one, then comes memory, and cache is the third one. So it doesn't really matter if your cache is at 4.5 or 4.7, the end performance doesn't really differ that much. 4.5 is relatively easy, so I might just set it at 4.7, it should still be stable. On the mainstream platform, so Z370 or Z390, the vCore affects both the core and cache. So there's no separate voltage for cache like on X299 or similar. So now let's test if 5.2 and 4.7 cache are still stable. You can also see my memory settings here, so 4133, 17, 18, 18, 28, command rate 2. And boom, it didn't even start. So I might have to correct myself, it might be the cache, because now it just hang. No blue screen and nothing. So it might be the cache, so I have to go back and retest this. So that's why it's not best to test multiple things at the same time. So it's hard to determine which one was causing the instability when I set 2 things at the same time. That is why it's better to just max out the core first, then cache the memory, for example. So we ended up at 5.2. I will leave the cache at 4.5. And now let's test again. If it runs, it was the cache, but if it hangs again or crashes, we know it was the core. And voila! So it's actually the core. So the cache was surely stable. So now we see that we can't hit 5.2 with this voltage. So we go back into the BIOS, and of course this also determines now how good your cooling solution is. But as I was always below 55C, I have much headroom to go higher in the vehicle. The maximum value I would use for like daily stuff is usually like 1.35. You can go up to 1.4, but I don't really like to go that high. And the temperatures are often quite bad already at that point. So 1.35 is the highest I would generally use for daily use. So for example, now I could just try 1.3 volts, see if it's still stable with 5.2. So I will put in 5.2 straight in the BIOS and see if it's still stable in the OS. Okay, so if we open CPU Z again, we can see that the core speed is at 5.2, but again the vehicle is reading all over the place, so you cannot trust this value. So we can open the Elite and check monitoring tab, and you can see it's 1.3 spot on pretty much. But of course all of these are always software values, so if you wanted to know the 100% exact value, both idle and under load, you need to use a multimeter. But I've already done that, so I don't need to do it anymore. So let's try R15 again and see if it's still stable and see the temperatures. Now it runs and it crashed. So it's not enough. So it might be that this is the max for this CPU, 5.2 I mean, to get for daily use. But let's see. As it was unstable, I just went straight to the max value I would use for daily use, which I already said. So now I have a vehicle value of 1.35. This is the max I generally like to use for daily purpose, because especially when you start to run those AVX capable programs, the temperatures get really high. So just bear that in mind. But anyways, let's try this again, but we already know that this will be the max frequency we can hit anyways. And it's very likely that it will be unstable very fast in AVX programs. But let's try this in Cinebench for now. Temperatures are still really cool, like 60 max. So temperatures aren't clearly my issue here. But let's just see this first. So ranging from 57 degrees Celsius up to 62. And it was stable, so 1713. Now I will not try it any higher because I know it will crash at 5.3 pretty much. So now I will just try the cache because it's relatively fast to try at this point. So I will go to the overclocking tab in Elite and I will set the cache to 4.8 from 4.5 and I will run it again. This doesn't really affect the temperatures, but the overall gain or impact on performance is really small. So that's why I don't really I don't often mind too much about the cache because of this. So even when I run parts on LN2, I don't always max it out like 100% the cache, because look, the score didn't really change at all from changing the cache from 4.5 to 4.8, but I can still try. I will just try 5 GHz. This might crash already. And it did. So 4.8 is probably the max it can do with this V-core. Let's see if I can reset. And I can't. So the difference between core crash and a cache crash is that if your core crashes, you can usually reset most of the time when you press the reset button on your case or on your motherboard. Sadly it shut down, but I was about to say, when your cache becomes unstable and it causes the crash, you can't usually reset, so it will just hang when you try to press the reset button, and it might do what my platform just did, so it shut down the system completely and then it rebooted by itself. So that way you can often determine the difference which is causing the instability. But now I want to show you the great impact on temperatures by the AVX instruction sets. So I will quickly show you the oops, that's the wrong ELIT. I tried to start. I don't want to use that. I want to use the light version. I will actually drop the clocks to 5 GHz for now. And the max temperature was around 60 when we ran Cinebench at 5.2, 1.35 volts. So let's open Pwm 95. So for some reason the newest Pwm 95 failed on this OS. I need to see what's up. But this is one of the older versions of Pwm 95. So this doesn't support any of the AVX instruction sets, and this already hammers your CPU a lot more than, for example, Cinebench. This is already quite good, so you could just use this to test your daily stability, but it will still not guarantee 100% AVX stability. But you can bypass that by using the AVX negative offset in the BIOS. So for example, if you can get 5.2 completely stable in this, you can use, for example, AVX negative offset of 2 or 3 in the BIOS. So that means it will run CPU frequency of 4.9 to 5 GHz for AVX programs only, and it will use the full 5.2 GHz overclock for everything else. So now I will put the clock speed back to 5.2. I need to check what's up with the Pwm 92 version. So, but anyway, so you can use Pwm 95 in small FFT, for example, and just let it to run. And this is already goes 5 degrees hotter than Cinebench, at least 5 degrees hotter, and AVX would be around 80 degrees. But for example, if you can run this for 1 hour full on, then it's already very, very stable from daily perspective, for gaming and so on. But if you want to get an overclock that's stable in everything, even in video rendering, which can utilize AVX instruction sets, then you need to use the latest version and enable all the latest AVX instruction sets, like AVX1, AVX2, and AVX 512 on X299. So I will see about that. Okay, so now I'm using a bit older version than the absolutely newest one. So this is from January 2018. Just stress testing, small FFT. So this is the version 29.4. Can I actually check that will it use so I cannot disable the AVX from here, but I will just as precaution first I will drop the frequency to 5 GHz, and this should use all of the available AVX instruction sets. So just be very careful if you want to run. You need to have a lot of headroom in your on your temperatures. So this can support AVX and AVX2. AVX 512 is only for X299 Skylake X. So torture test, small FFT, and run. So this utilizes the available AVX instruction sets, and you can already see that it went 15 degrees hotter than Cinebench R15. So bear that in mind. So if your temperatures are already like 70 to 75 in Cinebench R15, they can very well be 90 or even above 90 in AVX tests. So that's why it's good to have some headroom available when you test your CPU. Now it's only at 5 GHz, but I'm quite sure that it would crash at 5.2. So again, just like what I told when testing with non-AVX Prime 95, if you can run this for like 1 hour stable, then it should be completely stable. Some guys used to run this like overnight, but I'm not fully sure if it's required. Even just 1 hour is usually quite good way to determine if it's stable or not. And just out of interest, let's try to set it back to 5.2 and see if it crashes like straight away. Remember, it was unstable in Cinebench at 1.3 volts, but at 1.35 it passed. So I'm quite sure that it will crash straight away in AVX capable Prime 95. Cancel, so torture test. Yeah, it seems to, yeah, it's crashing. These two cores already failed. I will try it again. Yeah, it's not stable, so we know that. So as I said, if you, for example, run the non-AVX Prime completely stable for hours and hours at 5.2 GHz, 1.35 volts, you can compensate the AVX situations by using the AVX negative offset. So I would use a value of 2 or, for example, value of 3 there. So it would run 5.2 GHz in gaming, etc., web browsing, and in like AVX, in AVX rendering programs or similar, it will drop the core frequency to 4.9. So then you will remain stable in every situation. So let's try it quickly at 5.1. It might be stable at 5.1, but 5 GHz should be stable pretty much, quite certainly. This will go to 80 degrees roughly. There's quite a bit of variance, so 68 coolest and 79 warmest. But you have to run this for at least like 1 hour to know. And you also have to bear in mind about your VRM temperatures. If there's no heat, if there's no airflow towards the socket area and the VRM heat sinks on the motherboard, they do get quite warm very, very fast. So you should always have some good airflow aimed towards the socket area and the heat sinks. There were many articles, videos about this discussion back in the day when the X299 platform was released in June 2017, as pretty much all of the motherboards weren't capable of running those high core count Skylake X CPUs without VRM throttling. And it happens even with these 8-core Coffee Lake CPUs. So even with just frequency of 5 GHz, if you run something very stressful like AVX Prime 95 for hours and hours, the VRMs do get quite warm very, very fast. So as I have good airflow aimed towards the heatsink and socket area, as I set the hardware configuration to monitor the PWM temperature on the motherboard, I can currently read 42 degrees, 43 degrees right now for the VRM. As this CPU doesn't have hyperthreading, it doesn't draw that much power compared to the 1900K. It draws a lot more less. I mean a lot less power than 1900K thanks to the lacking of hyperthreading, because hyperthreading means 16 threads. It draws a lot more power than just 8-core CPU without hyperthreading. So just let this run. If this is stable, if this can run this for hours and hours, then I would just run 5.2, 1.35 volts with AVX negative offset of 1. So it will run 5.2 for everything else but AVX programs, and 5.1 for everything else like that can utilize AVX instruction sets. And that's pretty much it. Memory, just use simple profile like mine. I might do a separate video about that later, and I already have those on my channel if you are interested. And that's pretty much it. That's how you overclock your Core i7 9700K or pretty much any other modern Intel mainstream CPU to 5 GHz and beyond. This CPU ended up being a 5.2 GHz chip, so it's quite average, not a golden one. I still remember that the best 9900K did 5.5 GHz with 1.335 volts here, back like little over 1 year ago, which was the record CPU doing around 7 GHz in Cinebench, almost 7.1 in GPU Pi. So the quality difference between CPUs is very, very high. That's why it's called the Silicon Lottery. But anyways, so you can use this guide and you can easily determine how well your own CPU can do. But it really it depends a lot on your motherboard. Some motherboards are more capable on overclocking CPUs further than others, and also on the cooling solution. This guide video applies for Z390 Dark, so if you have these parts, then you can happily use this video. But other than that, thanks for watching, and I'll see you next time.